My name is Lauren, Lolo Coding on Twitter. Thank you for being here, everyone, today. We will invite folks to ask questions, to put your hand up, and we'll bring you up on stage as a speaker, and let's engage in a dialogue. But German, you're running the show today, yes?
Yes, indeed. Thanks, Lauren, for organizing this. And yes, indeed, we're going to be basically wrapping up and just summarizing how Decoded went and basically just sharing our impressions and discussing what's basically the future of smart contracts in Polkadot 2.0.
Okay.
And yeah, I
I
can
love
see
it. Okay,
that.
well, I'm going to let you be off to the races, and I'm going to mute myself. But if you have any questions, I'll be right here.
Sure, perfect. Thanks, Lauren. All right. Hi, Joshua. Hi, Cyril. I'll just give you the opportunity to introduce yourselves, and I'll start with Joshua. Joshua is from Pala Contracts. We met at Decoded, and he kindly agreed to join today's Twitter space as one of the co-speakers. So, Joshua, on to you.
Thank you, Gaiman. Hello, everybody. My name is Joshua. I'm the Director of Tech Evangelism at Follow Network. I was speaking with some of the people at Parity and the Ink team about some of the interesting things that are going on. So it's really nice to be here, and I'm excited to kind of share some of the thoughts and things that I saw at Decoded.
Thank you, Joshua. And now I'll pass to Cyril. Cyril is one of the devs at Parity. He works on Solang. And here you go, Cyril.
Yeah, hi everyone. Yeah, I'm Cyril. I'm working with like all kind of smart contract stuff within Parity on Ink, the contracts palette, but my main focus is really on maintaining Solang, and they're like specifically maintaining the Polkadot compilation target of the Solang compiler. So Solang is a Solidity compiler that can target our contracts palette runtime, and that's what I do. Yeah.
Perfect. Thank you, Cyril. And so, yeah, it's been, less than 2 weeks since Decoded. Again, beautiful city, amazing conferences, awesome people. And the first question I have for you guys is basically just want to ask you to share your impressions about Decoded. Just want to ask your general opinion, how it went for you, anything new you learned so far, and yeah, what are your impressions? And let's start with Joshua.
Yeah, so my impression was pretty good overall. I got to learn a few things. A lot of the time I was kind of working at the booth and then being able to introduce our technology at Follow with our fat contracts that we just launched on our mainnet on Follow Network. And then I was able to present a short little 20-minute demo about one of our products that we've built on top of our network. Some of the things that I was one of the talks I was like really interested in, and I learned quite a lot, was Hernando's talk about like Ink and like using a chain extension to sort of build out some like unique use cases using Ink and the contracts palette. So I thought that was really cool, and I had not known that Zeitgeist had implemented the contracts palette in their runtime, and then Interlay, him mentioning Interlay as another one that could implement the contracts palette was just really interesting because now you have like all these different use cases that you can start building out with the Ink contracts. Another really interesting topic was I think it was a Turn, if I'm pronouncing it correctly, but their XCM interface with the Ink contracts, I believe, is what they were presenting on, and I thought that was like really informative and some interesting ideas. One of the questions I have in mind, like just like from just to like the parity devs in general, is like that idea of like using chain extension for XCM calls. I'm not sure if that's possible. I haven't like really looked too deep into it, but I was wondering from my question like overall from the conference that I left with was if that's like something that you can add through chain extension.
Yeah, I mean, to answer your question, it is technically possible to use Axiom through chain extension, and there are a couple of demo projects. But our long-term vision, and like it's on our roadmap, is to actually introduce a first-class support for Axiom and through environment and functions. So you can you can send Axiom messages from your smart contract almost natively and seamlessly without all this boilerplate code of chain extension. Yeah, I know right now it's a little bit pain, but it's on our roadmap, and I think there's even a tracking issue for that. So yeah, and then I'll pass to Cyril. And Cyril, how did the conference go for you? I know you kind of work around public contracts, but you mainly focus on Solidity. So what's your impression? Let's say from Polkadot Decoded, and maybe how it compares to typical EVM Ethereum conferences.
Well, yeah. I mean, I spent most of the time socializing, getting to know all the parachain teams. I found it quite nice experience to learning about all our builders and seeing what they build with our technology. And yeah, it was super chill. And in general, yeah, I mean, if you go to an Ethereum conference, no one knows what is Polkadot. You can't really talk about the interesting stuff or Polkadot specifics or some cool tech we have, because nobody, virtually nobody, you have to find people who know our tech. So yeah, I quite enjoy this. It's I don't think it compares well to Ethereum conferences.
Sure. And do you have any guess why that might be the case?
Yeah, I mean we just do things differently. The Polkadot, the runtime, and this is not only for contracts, but in general, we have whole other novel approaches to things. How do you do blockchains really? I mean, we don't need, yeah, when you go to an Ethereum conference, it's all about roll up and scaling Ethereum, but in Polkadot, this problem doesn't really exist. So, and yeah, I think this is sort of what makes a huge difference.
Yeah, I do partially agree, and actually we're gonna come back to the tech, and we're gonna come back to the hybrid chains in Polkadot V2. But maybe the next question I have for you to kind of just slightly shift the discussion is maybe you can highlight a couple of talks that were impressive. I know, Joshua, you did mention the Hernando's talk about hybrid chains. Again, we're gonna just come back to this slightly later. But is there also anything else that you liked and kind of stick to your mind?
For me, one other one that really stood out was the Robonomics demo as well, where they're able to on chain be able to control a robot, and then based on if it were to pass or fail the obstacle course, it then would trigger another transaction on chain to then I guess the light bulb would turn green or red based on if it would pass the obstacle course or not. I thought that was really cool, and I always really liked the Robonomics project in general, because they always have a lot of very interesting demos that are interactive, that you can really tangibly see based on the work that they've done.
I mean, yeah, that's cool. I also had a quick chat with them, and their tech really seems to be promising, and there's so many applications in IoT devices and IoT networks with their tech, and I hope we'll get them on stage at some point. But let's move to Cyril. Cyril, anything for you to highlight from the conference? Hello, Cyril, you're muted. All right, while we're waiting for Cyril, yep, I'll just highlight personally, I've really enjoyed again Hernando's talk on hybrid chains, and I think it was well presented, and I absolutely love the illustrations that our in-house team illustrator Dima prepared. Kudos to him. Also, the other talk that I really enjoyed listening to was I think to do with multi-sig. To do with multi-sig UI UX. I think the project was called Multics, and they basically just simplified and provided a very nice user-friendly interface for you to manage your multi-sig accounts. And I think this is what essentially we need in Polkadot. Like we need to work on user experience and make it as smooth as possible for end users to work with our tech, because I think this is our kind of key to survival in the future. We have amazing tech, but we also need to have an amazing product and an amazing UI and UX to sell it to the end user. And Cyril, you still there?
Yeah, I'm back. Sorry. Yeah, but I was kind of like, yeah, Hernando's talk. It was really, really good. It was one of like the best talks I've seen in a while, and also like what he talked about. This is what I find like exciting about like smart contracts in Polkadot. Like I'm not necessarily excited about like there's a lot of other blockchains out there that are just like they're just like other smart contract platforms. But I mean, we have that in Polkadot too with like Moonbeam or A-Star, and like it's important as well. But it's really for me, it's really interesting to see like how these parachains, how these specialized chains like leverage the contracts palette, and then like what can you do with that? I mean, I find that way more exciting than just having like other or just more smart contract chain that still are only do smart contracts, maybe a bit better or different, but still. So yeah, this was Hernando's talk was my favorite talk.
I mean, I can also second that, and let's just move and talk a little bit more about the talk, because I think that was the main highlight of Decoded for Inc. is the Hernando's talk on hybrid chains. And just for everyone who didn't have a chance to listen to a talk or go to the conference, the idea behind hybrid chains is that you have two types of the chains. You have generic functionality chains like Ethereum or Solana or Near, and you have application-specific, like domain-specific app chains, like parachains and Cosmos, I think it's called app chains. And the idea that if you merge those two concepts, and you can essentially have a hybrid chain. You have a hybrid chain which still has some domain-specific logic, but at the same time, the chain can dedicate some of this block space to smart contracts, which would allow to have a generic functionality on the blockchain. And what that means that developers can essentially build a secondary applications and product leveraging the unique functionality that your blockchain provides. And what Fernando also mentioned, that it can also be used for substrate developers, for application developers to roll out features and fast-paced development. So instead of doing runtime upgrade, you can essentially just roll out a smart contract, test the functionality, collect the feedback, and with this user case story, you can essentially implement similar functionality in the form of the palette, and then do a runtime upgrade. So this allows you to do some sort of a quick prototyping, quick fast-paced evolution in terms of the code base. And this is partially already possible with the chain extensions. And the idea is that we were very glad to see like lots of parachains to essentially diving into this concept and essentially becoming hybrid chains. Again, as Joshua correctly mentioned, Interlay and Zkist already introduced Poly contracts on their chains, which would allow developers to essentially turn the application-specific blockchain into the whole ecosystem of multiple dApps that can essentially in future also interact with each other through XCM. So then I want to ask Joshua, what do you think would be the future of Fala? How would you see that? How would you see Fala essentially taking kind of position and role in this ecosystem?
Yeah, I think the Hernandez talk was really important, especially with these hybrid chains, because Fala is one of like the most unique like implementation of Ink and the contracts palette in general, because we've created we support the Ink contracts palette language in our off-chain workers, which are network. For instance, we have each worker remotely attested to be verified onto our network, so that we can then run these what we call fat contracts in these secure off-chain workers. And in this case, now you have the functionality of a smart contract running off chain. And also, we leverage chain extension to then make HTTP requests from the fat contracts, and also be able to use signing extension to derive key pairs for substrate based chains, and also like ECDSA keys. So that you can sort of like uh, interact with different chains without XCM currently, but you can also format XCM messages and send them through the HTTP request as well. But there's a lot of really cool custom functionality that we've enabled with the power of Ink. And one of the really most powerful things is we have this stake to compute model as well, so that you would just stake your Follow tokens, and then you get a percentage of the computation that's available in that cluster of workers, which is one to many workers in our case. Um, and then from there, all the power is through the queries. So you can then start connecting your on-chain dApps to like a quick configurable oracle that's able to access the internet. So it's kind of like like a secure and private by default a solution for you to start to build some like robust apps.
That's awesome. And again, like you mentioned, fat contracts many like lots of times, and just just for audience who people who might not have heard about fat contracts, and that you recently rolled them out on mainnet. Can you just talk a little bit more? What are the fat contracts? I know that this is off-chain solution, but can you just a little bit elaborate more, like what that means for developers? How essentially fat contracts are different from regular ink contracts?
Oh yeah. So fat contracts are the programs that are running off chain in our off chain workers, and in this case, they're quite similar actually. You can write your native like Flipper contract in Ink and deploy it into follow networks like off-chain workers. In this case, you can upload and instantiate that contract into a cluster and interact with it. So it's all supporting the vanilla Ink and everything, and also it just comes with additional customizations and the ability to make HTTP requests to get data off-chain to from different HTTP endpoints. So in this case, for developers, it's just a powerful tool for you to get some functionality that's programmable and supported in the language that you're developing in already if you're an Ink developer. And we can also connect to like EVM based chains for like smart contracts. And for example, what I demoed in my text talk, it was showing you one of our products that we've built on top of our protocol called Fat Bricks. But just to like not throw out all these terminologies that may be too confusing, just think of these fat contracts that I've been mentioning as these off-chain smart contracts in this case.
Sure, perfect. Thank you, Joshua. And one more question for you: and how does Fala ensures the authenticity of computation of those off-chain smart contracts? You did mention workers. How did they come in the picture? Like, what sort of the result of computation is committed on chain?
Yeah. So this part is done through the remote attestation process that we leverage through Intel SGX, because we utilize trusted execution environments to remotely attest the workers to be able to determine the hardware, firmware, and software, which in this case would be pink contracts that I say pink, Follow Inc. It's called contracts to be able to run the softwares that are the fat contracts in these off-chain workers. And in this case, since it's remotely attested, it's able to get a confidence level score, and this confidence level score dictates the type of computation that they can provide as a worker that's joined onto our network, and then they are added to a cluster of a bunch of different clusters that we'll have. Like for our first release is just the initial cluster, but this cluster has one to many workers, which then you can upload and instantiate what we call the fat contracts to be able to run your programs trustlessly. Because whenever you upload and instantiate it, you're able to get a contract key that's derived from the cluster key that represents your fat contract, and you can always use that public key to verify the computation through the remote attestation process. In this case, like you're able to verify the computation that's going through the contract that you have deployed on chain, and you can always report if there's like some kind of false positive or anything that could be nefarious that's going on with your contract by using the contract key.
All right. Thank you, Joshua. I just want to remind everyone.
I got a question for Joshua. Like, is any like ink contract that it's just like a normal ink contract, meaning like it can run on like an unmodified contracts palette? Is that automatically a fat contract? Or
so
do you need
inherently we can support that. Yeah, so you can write your regular ink contract and you can deploy it as a fat contract on our network. Yes.
Okay, yeah, cool. I was just wondering because if I could use Solang to write a fat contract in Solidity, which I don't think makes a lot of sense, but it would be apparently possible.
Oh yeah, and we have some like examples in our repos as well of showing like our interaction between Solidity contracts and then our contracts. I don't know if there's like a Solidity contract that would enable HTTP requests that off the top of my head, maybe like using like CCIP through Chainlink. I'm not really sure on this part.
Yeah, I don't know, but it's just so like in theory it would be possible. So
Awesome. Thanks, guys. Again, just want to remind everyone that again, this is office hours, just open discussion. If you have any questions for the speakers or for me, just raise your hand and we welcome you on stage. If you have also any topics to discuss with Ink Team or Fala or Solang with Serial, again, like you're more than welcome to either drop your question in the chat or raise your hand and ask the question on the stage. So unless there are no questions for Joshua Serial, I'll have one more question for Joshua before I move to Serial. All right, no questions so far. So what's next for Fala? So you introduced the fat contracts on mainnet, and what's next?
Yeah, so what's next right now is we're trying to ease the developer experience because there's not a lot of there's not too many ink developers currently. I'm glad that more chains are starting to add the contracts palette to the runtime because we'll start to inherently get more developers building on ink. I think Aleph Zero has like a pretty good community as well. They have like a lot of builders. For Fala, we've moved to this direction where we're providing these low code solutions for users to be able to generate what we call like a bricks profile. So the product's called Fat Bricks, which is prefabricated fat contracts that's built by the Fala team, and they're bundled up together to create what we call blueprints, so that you can have easily configurable blueprints that you can deploy to be able to interact with your dApps on multiple chains. So in this case right now, our first blueprint that we supported was a Lens API Oracle that's on Polygon for right now, but it directly translates because what I presented at the Tech Talk was like a generic Oracle blueprint that we would have, and the ability for either like EVM based contracts to implement for the EVM based chains, or substrate based chains based on integrating the off chain rollup palette into their runtime. And then for L1 Inc. smart contracts, also implementing the off chain rollup architecture so that they could interact with the FAT contracts and their customizable generic blueprint in this case. So we're really focused on trying to simplify the experience, get them deploying applications, and then once they want to learn a little bit more after they have like an idea of like a working proof of concept, then they can start digging into the details, and that's where we feel that we can start to get more organic builders and have more success with getting people to deploy on our platform.
Awesome. Again, thanks, Joshua. Next, I'll pass to Cyril, and the question I have for Cyril is that maybe you can just briefly summarize, again, just for newcomers, what is Solang, how it works, and how it's different from a traditional Solidity compiler.
Sure. So yeah, I said it's a Solidity compiler, but like in general, it emits like LLVM IR. So, and this is already like one of the major difference to like Sol-C. I don't know how many other Solidity compilers there are. I don't know of any other relevant one. And Sol-C, obviously, like it just emits EVM bytecode. But that's not very useful if you want to run your Solidity contract on the contracts palette. And it also, Solang also supports Solana. So because Solana, if you have LLVM IR and Solana have something like RBPF as their bytecode, and this is also like if you have LLVM IR, you can just like ask LLVM to emit whatever it supports. So this allows us to write a Solidity compiler that can compile Solidity contracts into, in our case, WebAssembly contracts. And then we add like Inc compatible metadata. And then, yeah, there you go. You can compile your Solidity contract and run it on the contracts palette. There are differences though, because like EVM is really that, like in Solidity, you can use assembly to write, yeah, they call it YUL, this assembly language for the EVM. And of course, like the palette contract does not support everything that the EVM does. So this is one example where you might encounter differences. So you cannot just take any Solidity contract and compile it for like the contracts palette. But in general, it works just like that.
Sure. Thanks, Cyril. And can you talk a little bit more about the differences between typical Solidity contract and Solang Solidity contracts? So what are the differences? So in terms of the support, what's supported right now, what's not supported, and what are the challenges?
Sure. So the contracts palette it's actually like the runtime and the execution model we have is actually not that different from like EVM or like what you have on Ethereum. But there are minor things. So there's just differences in the runtime. So for example, we would have like on Polkadot usually like the balance type is like a 16-byte long like number, and in the EVM world or in Solidity world in general, this is like a 32 bytes number. So you have to like truncate this or like be a bit careful about that. And then there's also like things you can't directly do on the contracts palette, but there's like just a runtime API that does that. And then there are things like chain extensions in the contracts palette runtime. This doesn't exist in Solidity, so you have to think about like, how do I expose this to Solidity developers? And yeah, these are a few examples. There's more. I mean, there's also like tiny details I don't think we need to go into that, but this should get you an idea like about the differences.
Sure. So can you talk a bit more about the team? I know there are a couple of other guys working on the Solang, and can you just give us a little bit background? So who's basically behind the Solang?
Sure. Solang is hosted under the Hyperledger umbrella. The Hyperledger is like the blockchain laboratory of the Linux Foundation, and this gives us like great traction. And we have right now, it's me working on the Polkadot target. There's 2 people from Solana Labs working on the Solana compilation target. And then we also do like mentorships with Hyperledger. So we have like students implementing some stuff. And yeah, I see like Sean is one of the other maintainers. He's here in the Twitter space as well. So yeah, we're a tiny team, but we make this work.
Oh, Sean is here. Hi, Sean. If you would like to jump on the stage, feel free to. If not, no pressure. And you did mention that you have a mentorship programs, and that's actually a very interesting concept. And could you please share a little bit more about mentorship programs that you're currently working on? Do you have any mentees? What's the like project that you're in?
Yeah, I have a mentee. Like we have 3 mentees. So this is a Hyperledger thing. So like I think one of the most popular things from Hyperledger is they have an Ethereum client. And so like every Hyperledger project can apply to get mentees that then do like a specific task. And yeah, it's like sort of like an internship, I guess. So yeah, and it's great to see like to work together with these mentees, and they can learn, and they can actually they are usually pretty good as well. Like they get stuff done. So yeah, this is a good thing to have.
What are the projects they're currently working on?
Sure. So right now, like we have, like what I'm doing is like, you can't use cargo contract to deploy like when you compile a Solidity contract with Solang and then you want to deploy that, you basically have to use the contract UI, because cargo contract, what you would use for Ing, expects like a cargo.toml. It expects your contract to be a Rust project really, but this does not fit on like Solidity. And then like we want to have a CLI tool like for ourselves, so that I'm like when you can just deploy your contract and call it without going to some some JavaScript code or some web front. And then this is what what one mentee is working on. We have another mentee working on like making the language server functional. And then we also want to have like we basically want to rewrite our internal representation of the Solidity code into an SSA-based format. Like this is going into like very compiler development specific things, but so not going too deep into this. But yeah, this is what they do.
That's actually a very interesting concept and the program, and like I just wonder whether it's something that we can have for Ink or anywhere in Polkadot ecosystem. I know we have the concept of fellowships, but that's basically for a generic Polkadot development. I don't think that fellowship actually covers smart contracts in Ink. So do you think this is something we can also introduce to Ink and potentially other parachains that are introducing smart contracts?
Sure. There are tons of students that are like actually capable, and they are seeking for like contributing somewhere. I mean, especially like probably all the parachain teams, like probably like almost all their code, like everything they do should probably or is probably open source anyways. And there are many students looking out for opportunities to like make contributions to some open source project. And like one of the maintainers of Solang, he was like a mentee once as well, and then like he's now working full time on Solang. So you can like you can pouch really good students early on if you try to convince them to make a practical. So yeah, I can really recommend this to everyone.
And Joshua, what are your thoughts on that?
And this is you said the Hero program? on this?
There we go. Yeah, this is the Mentee program, the mentorship program.
Yeah, I think I do think this is like really important because having more of like the people that are building an ink, and then having them to also like guide some of the new developers that are interested, to kind of shorten that time to get started is really important. And then having some community feedback, and then us as we all like interact with other developers across the world, being able to bring that feedback together and then start to create some effective strategies to then start to target, especially when it comes to like a tool set that developers need so that they feel comfortable building an ink and they want to like start moving forward. That's why I really do like this the Solidity compiled down to WASM bytecode so that you can load into the contracts palette, because it makes me think that we have this like off-chain roll-up like action request queue that we have implemented in EVM, and I was wondering if it's able to be used on EVM chains, then we could use this is it Solang compiler to be able to then use it for ink as well, like for like in the contracts palette, if that makes sense.
Yep. Awesome. And unless again there are no questions for this topic, I have one last thing on my agenda before we kind of move on to open discussion. Is about Gav's talk and his idea of core smart contracts, and I just want to ask you guys what are your thoughts on that. How do you think it basically aligns with your personal vision of the role of smart contracts in the ecosystem, and maybe how we can potentially also link it to hybrid chains? And I'll pass to Cyril to start with.
Yeah, I think I missed the first. It was the first part when he was talking about that, right?
Yes.
Yeah, I think I missed just the first part of his talk. So
Oh yeah, no worries. Joshua, you have any thoughts on that?
Yeah, like some small thoughts. I haven't really. I've read through the presentation, and it's kind of like a little bit like a little similar to like kind of the language that we started using at Follow whenever we wanted to move away from like miners and start calling them compute workers, and starting to like kind of build the right language about one, like what the capabilities are, and make it more like more appropriate for like descriptive terminology when it comes to like technically describing what's going on underneath. And then also like the future like that he kind of elaborates on. I have to like, it's different, like these are different like mechanisms of being able to run, I guess, parachains with these I don't know, like I saw something about like a hybrid like lease model for parachains, and then there's like this idea of like running smart contracts on cores. I yeah, there's a lot of things that can kind of like come from this. I don't know how to interpret quite yet. I need to really think about it for a while, but yeah, it's really interesting, and it seemed to be a big talk right now. I want to like kind of dive in a little deeper on it to better understand, so I can kind of join the discussion. But it's
Yeah.
I thought it was pretty interesting talk
Yeah.
overall.
Yeah, I can definitely confirm that there is a lot of content to digest and process and discuss in future, and that my whole Twitter feed is basically kind of, it's completely full of his talk analysis, like multiple Twitter threads about like a summary of his talk. But again, this concept of core times, I think like we also partially discussed it inside Ink team. It's basically, I think it's with the ability to kind of run a smart contract as a parathread. So the idea is that you can essentially, when you, again, this is how I interpret it, like correct me if I'm wrong, but like I think the idea is that if you're running on top of L1 chain, that you essentially also relying on the availability in the block space of that specific blockchain. But if you need some extra exclusive block space, then you can essentially lease a power thread and get the whole block space exclusively to your smart contract to your needs. If you if you go to high TPS and lots of transactions in your application get traction. And I think that's kind of like how smart contracts fits in the model of, kind of reimagining Polkadot not as a parachains, but like cores and applications running on top of the cores. But again, this is like a huge topic to discuss right now, and then it can potentially, I think, in future, simplify the perception of Polkadot as like, I think what also Gav introduces is one single kind of decentralized computer. And this, I think this is also like kind of general trend in blockchain space to kind of simplify the concepts, simplify the definitions, and sort of, calling parachains, then kind of, imagine the whole blockchain space as one global, trustless and authentic computer. And yeah, so again, just remind for everyone that if you have questions and like you want to discuss anything, just raise your hand or drop a question in chat, and I'll pass it to one of the speakers. But I think that's it. What we covered on the agenda, and then the question I have for you guys is: there anything else you want to ask each other to talk about?
Yeah, I was wondering. I kind of asked it. I don't know if I asked it right. It was that we have this this action request queue like as a roll up anchor. That's an EVM smart contract, and if we use this Solang compiler, then we could then say load that compiled wasm blob into like Astar's contracts palette in this case for the same functionality as like a ink smart contract in this case.
Yeah, that should work. I mean, you need to try to compile that contract, and it always depends what the contract does. Like one of the most like deal-breaking things is usually if the contract calls into a precompile. And like this is the case, for example, with all these zero knowledge stuff. It just needs the BN, the elliptic curve math precompiled contracts, and they don't exist on the palette contract. So if your Solidity contract like calls into like one of the precompiled contracts, then it's like tricky. Like what can you do about this? But if this isn't the case, then it should probably work. Maybe we can chat or we can connect afterwards to like try and see whether it should work or whether it would make sense at all.
Yeah, definitely. Yeah, I'll connect with you after, and I'll probably try a test later today when I get some time.
Sure. Happy to like help out and experiment with this. Sure.
Awesome. Anything from you, Cyril? Anything you want to ask or add?
No, that's. I mean, I'm the one who is supposed to answer questions.
All right. Then I have a question for you, Cyril. So I know, like, again, correct me if I'm wrong. Like in Solidity, the constructor isn't really included in the final blob, in the final binary that's deployed on chain. I think that when the Solidity contract is compiled, it's not exactly the compiled binary is not the binary that goes on chain. It's kind of a deployment binary, which is then executed on chain and deploys the contract. And I know that in Ink, the binary that you basically compile is the binary that gets deployed on chain and then instantiated. And essentially, the constructor is also part of the binary. And how does that work with Solang? Do you still kind of chop off the constructor from the Solidity contract, or does it get included in a binary?
No, if you wanted to do this like the same as like it's done on Ethereum, then like it does work on the contracts palette, because the contracts palette still expects like your contract to export a deploy function, and then you will upload the code, and then on instantiation it will just call that, And if export is missing, like it doesn't work.
Okay. So you're essentially saying that the construct does get included into the final binary.
Yeah, sure. I mean, it's the same for inc contract.
Yep. Okay.
I mean, otherwise, the deploy function wouldn't know what to do. I mean, this is like one example of like the two runtimes being really different, having like different ideas about like how this contract instantiation should work.
Okay.
But it's not really a problem. I mean, you can just you can just take the constructor from the Solidity contract and then include that, and this still works.
Sure. And the next question I have about the cross-contract calling. I know like there's been a couple of issues with the kind of data types compatibility, that some data types, like typical data types in Rust, like result and option, are unavailable in Solidity. And I know this is kind of known issue. And kind of what's the status for that?
Yeah, so the problem is if you're like, imagine you deploy two contracts, one is written in Ink and one is written in Solidity. And then you try to make them work together. You try like to call like one from the other. I mean, sure, this works, but what if your Ink contract has like an optional function argument and returns a result? How do you express that in Solidity? I mean, you can't really express that in Solidity. There's no way to let Solidity know like, oh, like this contract returns a result, so you need to decode the result. So, I mean, it still works because the scale encoding has like very clear ideas about like how, for example, a result is like encoded and decoded, and then you just have to kind of re-implement or like mock that in Solidity. And yeah, I guess this is like what you would do in any other language that deals with scale encoding and does not necessarily have all the Rust types. Scale I think was made to be not like to work with many different languages. So it works, but you have to manually take care of like decoding these types the correct way. And like maybe someone builds, or maybe we will build it when there's time for it, some helper library to just make it a bit easier. But for now, like we don't have time for that. But only because types are different doesn't mean it doesn't work. You just have to be a bit more careful about that, or yeah, think about like how you do this. Does that make sense?
Absolutely. And so then if you said that there's not enough time, what's the current kind of issue you're working on or the team is focusing on?
Well, a compiler is like a big complex piece of software, and yeah, what I'm working on right now is like really getting the open sapling contracts to like work well for the Polkadot target in Solang. So I'm usually like taking a look at some of these open sapling contracts, or also some real world examples, and then like trying to see like what's missing, and then just implement that, or like fixing bugs. And yeah, this is already taking a good amount of time. And also a while ago, I took the Tornado Cache core implementation contract and then made them work with Solang. And this is like, as I said, this is a problem when you don't have the precompile, which the Tornado core, like the snark verifier, calls into these precompiled contracts, and then you can just implement these as a chain extension on your parachain. And then I just did that, and now like Tornado core is an integration test for Solang. So this is, for example, something I'm working on.
So you did mention that you managed to work to make Tornado Cache work on Solang and Pally contracts. So what about the performance comparison? How does performance compare to EVM deployed Tornado Cache contract?
Well, I mean, it's the most expensive part by far. Like if you like what you do with Tornado Cash, if you do a withdrawal, your contracts needs to verify the proof for your commitment that you like deposited firsthand. And this, I made some like very, very basic and very unscientific benchmarks on my computer. And it turned out like the chain extension that does the pairing operation, which is used and it's during the verification of the proof, and it's like the most heavy computation we'll do. It takes about 6 milliseconds in the runtime on my like 3 years old desktop computer. And I think that's somewhat representative for real nodes as well. So just as a like very, very broad estimate. And 6 milliseconds, so the contract will really, if you do a withdrawal, it will really use like the ref time of what is 6 milliseconds plus some extra, because the other work you do is not very expensive in comparison with that. And this gives you like a rough estimate. And 6 milliseconds is like a lot of time for a smart contract to execute, I guess. But what is the comparison compared to EVM? Like, I don't know how, like, I guess the EVM is fairly efficient. These precompiled contracts are fairly efficient as well. But then again, the gas costs on Ethereum are like very, very high. So realistically, you would try this out on Moonbeam, and then you would just see like what transaction costs more. But yeah, if you want to try this out, I would be interested to know as well.
Sure, yeah, you can have a chat after. Thank you, Cyril. And then the question for Joshua. So, Joshua, what's the issue you're working on right now?
There's a few things I'm working on. Mostly just developer experience and like producing like better documentation content around how to build on Fala. Kind of clearing up some of the technical language as well. Like earlier with the verifiable computation question, I misstated I said contract key and I meant to say worker key. So there's some like some technical descriptions that I could probably add to our docs that could better explain the way that we have like verifiable computation. And so mostly it's fully focused on the developer experience, and then also just building some dApps for dog fooding the fat contracts that were built on our protocol.
Awesome. Thank you, Joshua. So I think we're approaching the end of the session. I'll just kind of pause for a minute for the audience to think about the questions. Again, if you have any questions, you still have time to ask. And again, don't hesitate. This is just basically kind of a very informal discussion and opportunity for you guys to connect with the developers in the ecosystem. Again, if you're not comfortable asking questions today, you can always pop in a question at Stack Exchange or connect with us on Twitter, or just DM me a question on Twitter, or open an issue on GitHub. And again,
Wonderful. German, you have done an incredible job hosting today. So let's give him a round of applause with emojis, perhaps. But yeah, thank you, Gerben, for fostering such a thoughtful conversation, and for our guests for joining and reflecting upon Decoded and sharing all the things that you're excited about for the future. Folks, will have a recording of this up on YouTube later on. And of course, we do these the first Wednesday of the month. So the next one would be August the 2nd. And we'll try to keep our conversation timely about what we're working on in the world of ink in that time. But otherwise, for now, I think we will sign off and say thank you again for everyone who joined.
Thank you, Lauren.
Ta-ta for now. Goodbye.
Thank you, Joshua. Cyril.